Today we're looking at Keeper 4.8, Logarithmic Differentiation. Alright, so the steps that you need to be able to do this is to simply, step 1, take the natural log of both sides of your expression. Use your properties of logs in natural logs, so like your power rule, your product rule, and your quotient rule for logs, not derivatives, to simplify the expression. Then you're going to differentiate both sides, and then finally multiply both sides by f of x or by y. Alright, so here's an example. We have y equals x to the 3x minus 4. The reason I have to use logarithmic differentiation here is because I have an x in my exponent, so I need to figure out a way to drop it down. And we know with logs we can drop exponents down. So I'm going to use logarithmic differentiation to solve this. Now my step 1, I'm going to take the ln of both sides. Step 2, I'm going to use my properties of ln, which is simply just to drop my exponent down in this case. So I have 3x minus 4 times ln x on the right side. Alright, now that I use my properties of logs and I got it to where my exponent is no longer up there, that x is no longer in the exponent, I'm going to simply take the derivative of each side. Now the derivative of ln y would be 1 over y dy dx. Remember, every time you see a y and you take the derivative of y, you need to put the dy dx. And then on the other side, I have to do my product rule. So I'm going to do first, which is 3x minus 4, times the derivative of the second. The derivative of ln x is 1 over x, plus second, which is ln x, times the derivative of the first, which is 3. Alright, from there, I'm going to simplify it, clean it up. So I have 1 over y dy dx equals 3x minus 4 over x plus 3 ln x. And then my very final step would be to get rid of this y here, because you have to remember we are solving for dy dx, so I don't want the y over here. So I'm multiply both sides of my equation by y. And then I'm going to go back and plug what y is into my formula. So I multiply by y. I have this y over here, but I have to remember that y is actually equal to x to the 3x minus 4. So I'm going to take that and throw that back into my equation, and this would be my final answer. Alright, for our last example, I want to show how you can use logarithmic differentiation in cases where it's not necessarily the problem where you have x in your exponent, but just you want to be able to simplify the problem and make it a little bit easier to solve. So in this example, we definitely could have used like product rule and then chain rule to try to solve it. But we can also use logarithmic differentiation to solve it and make it look a little nicer. So again, my first step, I'm going to take the log or the ln of both sides. On this right hand side, I want to simplify that using my log rules. Now if you've got your log rules, you need to jot them down. And so the first log rule is your product rule, where if you're multiplying within a log, you can change it to addition. Then you have your power rule that says you can drop your exponents down. And then you have your quotient rule that says if you're dividing within a log, you can make it subtraction. Now in this particular problem, we have multiplication within our log, so we're going to make it addition, and then we're also going to drop our exponents down. So when I do that, notice I haven't taken the derivative yet. I'm just simplifying the ln's, and when I do that, I get 5 ln 2x minus 1 plus 6 ln 3x squared. Now if you need to see those steps, or you need to see the log process of it, I have it written over here to the side. Again, all I did was make it addition since it was initially multiplication, and then I dropped my exponents down to the front. Once I have that done, all I need to do is take the derivative of both sides. And so again, I'm going to take the derivative of ln y, which we know is 1 over y dy dx. Again, don't forget, when you take the derivative of y, you have to add that dy dx. And then that equals the derivative of 5 ln 2x minus 1. So that's 5 times 1 over 2x minus 1 times 2 plus 6 times 1 over 3x squared plus 4 times, again, the derivative of the inside, which is 6x. Simplifying that, I get 1 over y dy dx equals 10 over 2x minus 1 plus 36x over 3x squared plus 4. Now that it's simplified, again, I want to get rid of this y over here because I have to keep in mind that I'm solving for dy dx, so I don't want this y over here. So I'll multiply both sides by y. And then my last step, instead of having y in my problem, I want to substitute that back out for the original equation. What was y actually equal to? Or y was equal to the original, and I'm going to throw the original into my expression for y, and that would be my final answer.